So, um, so first of all, I'd like to tell you, if you look at the whole thing, right? You should always remember that when you're drawing this graph of acceleration versus displacement, you should always remember that whether the displacement is here, it will have a negative value here because both are vector quantities. A will here, the negative acceleration is going to be here. So the graph is going to be of negative gradient. The reason why it is negative gradient is because it's because when you see uh, the equation, it is a proportional to negative x, which means that when you have the maximum displacement, which is right here as x naught, which is the maximum one, then you also have the negative maximum acceleration, which is, let's say, a naught. Do you guys understand this, what I'm saying? And when we have a negative maximum displacement, which means then obviously your display acceleration is going to be maximum, but it is going to be positive. All right. The other thing you should remember is that this graph always crosses origin. The reason is that when you write the equation as minus omega squared x, this represents y equals to mx. That's a math equation for a straight line passing from the origin. So what we have done is we have drawn acceleration y-axis, we have drawn displacement on x-axis. So naturally, when you are looking for the gradient of this equation, the gradient is going to give you minus omega squared. Do you guys understand this? All right. So these things you just need to remember, be very careful about that it should always go like this. Now, let's look at how you can write this down and then I'm going to go forward. All right, now let's go to the next thing. For example, in this question, they have given you a graph and they say that's the variation of displacement y of x when some sand is sprinkled onto the plate and plate is going up and down as you can see. First of all, it says use figure 2.2 to show how it can be deduced that, oh no, I hope this stays. Okay, wait. This, oh, thank God. I was scared for a moment. All right. Show how it can be deduced that the sand is going under simple harmonic motion. First of all, we are going to write that the magnitude of acceleration is increasing proportionally with increase in displacement. All right, so this should be the first thing you should always write. And the other thing for the other mark is that the direction of acceleration is always opposite to the displacement. Because why do I see this? Because I just, like I explained it to you, that when this is positive, this has to be negative. Do you guys everybody understand this? Please let me know. Okay. Now, so then, speaking of this, then it says calculate the frequency of the oscillation. Now, obviously, when this kind of graph is given, so you should remember that the gradient of this graph has to be negative omega squared, which is basically 2 pi f whole square. And this is how we're going to get the frequency. So we're going to end up finding the gradient. So let's try. All right. So first of all, you can always take just one point as 0 and 0 because this will always be there. And then the other point, you can take anything you like. Right now, I would take 8. And this is somewhere here, which is exactly in the middle, which means this is negative 4.5 meters per second. And then I'm going to also check what are the units here. So then to find the gradient, what I'm going to do is I'm going to say the negative 4.5 divided by 8, and I'm going to multiply this with 10 raised to minus 3 to convert it into meters. So this will be equal to 2 pi by f whole square in the negative value, because negative negative would cancel out. And then you can take under root of 4.5 divided by 8 into 10 raised to minus 3 and 1 upon 2 pi. This will give us f. Anybody who can please help me with calculating this would be very nice of you. Go on, hurry up, please.
3.77 hertz.
So we can write it as 3.8 hertz to two significant figures, as we have the same in our data. Then it says the amplitude of the oscillation is gradually increased beyond 8 millimeter. The frequency is constant. At one amplitude, the sand is seen to lose contact with the plate. For the plate, when the sand first loses contact with the plate, state the position of the plate. Obviously, if you realize this, when it's going to be here at its maximum displacement, this is when it is going to have an acceleration downward, which is also maximum. If the acceleration of the plate and the acceleration due to gravity is equal, then what happens is that the sand will seem to just lose contact as the reaction force and the gravitational force are basically somewhat equal. All right. So, which means that I'm going to say it is going to be at maximum displacement at the above position. All right. So because at bottom, it would not do the same because at the bottom, it will be accelerating upwards. So that's why it will create some greater reaction force. Is that clear, everyone? All right. Now it says when it loses contact, we should remember that the acceleration of oscillation should be equal to the acceleration of gravity, which means that now this should be 9.81, and we know it is going to be 2 pi f. We want to find, we have the frequency actually, 2 pi f whole square multiply by, you can put a negative sign if you want to. Otherwise, you just need to find the magnitude. So you can ignore that as well. It's all right. And then you need to find what? You need to find the displacement, right? The maximum one. So we're going to do 9.81 divided by 2 pi and 3.8 and whole squared. Would you help me find this, please?
0.017.
0.017 meters. And now they've asked you in millimeters. Always check that because sometimes, you're in hurry. So if you want to change it into millimeters, you got to multiply by 1,000. So it's going to be 17 millimeters. All right. Okay. So Ahmed Squares, Mokshil Munib, Nadia, Man Tanjan,
Yes,
Ahad,
sir. It's clear.
Kafir. Everything is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Very good. Very good. So this condition that I've told you here, I was expecting what you asked me. Yes, Joelia.
This might be a stupid question. How did you get 2 pi f, the whole square, times this maximum displacement? How does that equal to the acceleration of gravity?
It is A equals to this, right?
Yeah.
So A equals to minus omega square x. A is minus 2 pi f, like this.
Oh,
Do you
and then
understand?
times r. Sorry. Yeah, I think r. Yeah.
Square on top, right? Like that. Because we found frequency, right? That's why. You could also use the gradient if you want to, if you found it separately. I didn't do it. So this condition that I was talking about is only possible when it will lose contact at top position. Otherwise, it is not possible in any case. So you should remember that. All right. Now, speaking of this then, the next question, it says by reference to simple harmonic motion, what is meant by the angular frequency? Okay, who's going to tell me that, please? Hurry up. I know you guys know. Nobody knows in this class. That's not fair. Okay, don't worry. All right, let me just write it down. So, speaking of angular frequency, you just need to tell them that with reference to this, angular frequency is the angular displacement per unit time to complete 2 pi radians, in a particular time period. All right, so that would be angular displacement. Understood? Because this is one whole rotation. Do you guys understand what I'm saying?
But sir, how does this refer to simple harmonic motion?
Okay, because in circular motion, if we just draw like 120 degrees, right? Or something like that. So Gatika, whatever that theta is, this theta, and it has gone through time t. So we say angular displacement is, angular frequency is theta by t, right? Do you agree?
Yes, sir.
But when you complete the whole rotation, so basically oscillation means a whole rotation. So whole rotation means it has gone through an angle of 2 pi. And how much time it does it take? A time period. That's what we need to explain. Understood?
Yes, sir. Got it.
Okay, very good. Now, so this is another question. This is a different type of graph, but do not worry, because you see the place where it crosses, they have given just the displacement. This time, this is not something like starting from 0. It means you're going to consider this point as the origin of the graph. Do you guys understand this? Which certainly means that actually when the acceleration is going to be somewhat like, this, which is, I believe it's 0.9, then the displacement is not what they have written. I mean, displacement is not what they've written here. In fact, the displacement is 3.5 minus 2. Do you guys understand this?
Yes, sir.
Okay. And in this case, where the acceleration is 9.5, then actually the displacement here is 0.5 minus 2. So one will be positive, one will be negative. Is that clear? So basically, they've given you a false origin so that you guys get confused, but do not get confused. It's fine. Now, first of all, they say the displacement of the load before it is made to oscillate. Obviously, this is this displacement. So we're going to write 2.0 and check whether it's centimeter. Yes, it is in centimeter. Cool. And then it says the amplitude of oscillation. So amplitude will be 3.5 minus 2. So it's going to be 1.5 centimeters. Understood? Please check this and let me know if you do not understand this. Okay. All right, both Ahmed, Saman, Mokshit. Today, Mokshit is very quiet. What happened? Is everything all
Sir,
right?
actually, my laptop is it's on its edge of the battery. I'm just logging on onto another device.
Okay, okay. All right. Okay.
Sir, could you
Then,
explain this question again, please?
yes. So actually, if you look at this, this is like simple displacement. Okay, Mani. So
Yes, sir.
check this out. When the acceleration is minus 9.5, basically it shows you a displacement of 3.5, right? It
It's minus
basically
0.95.
means, yeah,
No?
3.5. No, it's 3 and in the middle, this will be
No, I'm
3.5 and
saying
then
the
4.
acceleration. I was talking about the acceleration.
Yeah, it is, yeah, okay, sorry. 0.95, okay. What I'm saying is, suppose they're saying when the displacement was 0, so they have given the actual distance, like this length is 2.0. Do you understand? So when the object is in motion, so when it has the highest displacement, so it is at the length of 3.5. Do you understand? And when
Yes.
it is at the lowest, then the length is about 0.5. Do you understand? So if I want to find the amplitude, this would be the mean position, right? So this is the mean position at exactly 2. You agree? So if I want
Yes,
to
sir.
find the amplitude will be this one. So it's going to be 2 minus 3.5, 1.5. And same goes for the other one, negative 1.5. Do you understand? Like that.
Yes.
So they've given you a false origin just to give you, a headache. That's all.
So we should always
Then,
take the
Okay.
origin from the y-axis. Even if it's not
Wherever
zero.
wherever it crosses one axis, that should be origin, whether X or Y.
Okay.
All right, is that clear? Now, then it says show that the load is undergoing simple harmonic motion. So this is a very similar question that we did just now, right? So how do we write this? We are going to say that the maximum magnitude of acceleration is at the maximum magnitude of displacement. All right, so it's 1.5, as you can see. So that's 1 mark, right? Then the other thing is that it is a straight line, shows acceleration is directly proportional to displacement. Now, the third mark shows that the negative value of acceleration when displacement is positive shows both are in opposite directions. All right, is that clear, everyone? That's what you should do for 3 marks, basically. Okay. Now, then it says calculate the frequency. Now, again, it's pretty simple. You just need to assume that this is 0 and 0, which means that this change is 1.5 centimeters, and this change, as you can see, it is minus 0.95. So what you're going to do, you just need to take the gradient of this. And the issue with this is, as you can see, the graph lines and the graph is sort of flipped. Okay. So you don't have to worry about it. You can simply, you know, that acceleration is proportional to or minus omega squared x. So acceleration was minus 0.95, and this was omega squared, and this is 1.5 times 10 raised to minus 2. Why 10 raised to minus 2? Because I need to change it into meters, as this is in centimeters and this is in meters. So then minus and minus will cancel out. So 0.95 divided by 1.5 times 10 raised to minus 2 whole squared will give us omega, which is equal to 2 pi n f. So 1 upon 2 pi will be 0.95 divided by 1.5 times 10 raised to minus 2 whole square. So this will give you the frequency. Can you please find this?
So it will be 0.95 or only 0.9?
0.95. Is it 0.9? I think it's 0.9, right? It's in the middle. Yep,
Yeah.
0.9. Yes, sorry. Okay, it would be 0.9000. Okay, let me copy this. Let me take it here, where it belongs. Right here. Okay, could you please find the answer? Hmm.
573 hertz.
23 hertz.
573 hertz.
573 hertz. Okay. 573 hertz. All right. Isn't it a very big value? Don't you think so?
Yeah, it
I
is.
think so.
You should have
So why
taken
have
the
we squared?
yeah.
So shouldn't it be a rule?
Oh, we have to take under. Oh my goodness. Sorry. So bad. All right. This was like very big. So I was like pretty confused. All right. Could you please tell me what is the answer now? I'm sorry, Gatika, for all the trouble you have gone through.
No problem, sir.
Okay. And what do you think it is now?
1.23.
1.23. Okay, pretty good. 1.23 seems okay for these values. All right. Now, the next question, which I'm going to do, and the rest of the ones I'm going to give you. Any questions now? Please let me know before I proceed. Okay. All right. So now going to the next question. It says, state what is, by reference to displacement, what is meant by simple harmonic motion? Okay. So I'm going to simply, if I were you, I would write that the magnitude of displacement is directly proportional to the magnitude of acceleration, right? So this question is always there. Then the acceleration is always in opposite direction to the direction of displacement. If you don't want to write this long, you can always write the acceleration is always directed towards the equilibrium or mean position. All right, so that is also a perfectly valid definition. All right, everybody understands this? Okay. Now, so who can tell me why this is not following the rules for simple harmonic motion? If you just look at it for once, let me know, please.
One of the first things you can see is that it's not a straight line. It's a bit curved.
Yeah. So we can say that number one, it is not a straight line. All right. Which means, okay, you can, if you want to write further, you can say that acceleration is not directly proportional to the displacement. All right. Magnitude, by the way, just add magnitude. Yes. Anything else that you see?
So the magnitude is different.
How? Do you think the magnitude is different? Like on both sides? Obviously, the magnitude is different. That's why we've written that it's not proportional. What else? What else? Anything else you know? Okay. Anyway. So, what the next thing you should always say that if the max, if you look at the thing and you see the graph from here, you might realize that this point is right here, somewhere in the middle of the graph, and this is right here. But if you look at this is way different. Do you guys see the difference?
So this is what I meant.
So the oh, sorry, you're right. I'm sorry. I thought you were talking about overall. So if you want to write this, you're gonna say the maximum displacement. Also, you can write acceleration, right? Is different on both ends. Do you guys understand this? That's fine. So you can always check the maximum values as well. Any questions now?
So if I were to talk about the gradient, it would go in line with the first point though, right? It's not
Yes, gradient
a
is
straight
should be.
line. Yeah, so it should be the same meaning. So I won't get a second mark if I would write gradient.
Gradient. The gradient
Yeah.
on both sides is different.
Yeah.
Maybe they might give you that. Maybe. But this is just a tip that you should always check the both ends and whether it's a straight line with a negative gradient, right?
Yeah.
So you can write this down. Just write this down this point down, because probably you are not going to see such questions a lot, and if they come, you should always have an idea. Then comes this question where it says you have a graph, and the very first thing that you should always notice about any graph of this sort is that you might see that the peaks are getting smaller and smaller, right? So it's basically a graph that is going simple harmonic motion, but also damping is being done here. Understood? So first of all, let's check the angular frequency. So to find the angular frequency, I would recommend that you take one trough or one crest. It's up to you. So one is 0, the other is 0.8, and check the units, it's seconds. So omega is 2 pi upon t. So 2 pi over 0.8. Please tell me what is that?
$7.85.
7.85. That is all? Really?
Yeah.
Okay, cool. All right. Then it says the maximum vertical acceleration of the block. So the maximum displacement would be right when it is at maximum acceleration when it will be at maximum displacement, which is right here. Taking this point would be wrong, because by taking that point, this is when it has lost some energy already. So you don't have to take that. You have to take whatever the maximum value on the graph is. Do you guys understand this? Then you're going to say, all right, the maximum, the x naught here is negative 1.5. And I want to find the acceleration. So I'm going to use a naught minus omega squared x. This is going to be 7.85 whole square times negative 1.5 times 10 raised to power minus 2, because that was in centimeters. Can you find this, please? Go on. If everybody solves this, Gatika will
So
not be alone.
0.92.
What do you guys say? All right. Now,
So 0.925, no, 924, sorry.
okay, so that would be 9.2 then. Okay. Now, then it says the block has 120 gram. The oscillations of block are damped. Calculate the loss. Oh, this question comes from much later. So I'm going to give you this as homework. Homework for later. Okay. When we are done with energy. Anyway, now going to the equation part. Now, speaking of the equations, I just want to tell you, these questions will be always there. The questions are very simple. They'll give you an equation, and they will always ask you that whether this equation represents simple harmonic motion or not. The only thing you need to check is that this is displacement, this is acceleration, and then you compare this equation. So always make sure wherever the displacement is, just separate from the equation. So if I separate it, it's going to be minus g over r times x. Can I write it like this, please? Once I've done this, then I can simply basically put it against y equals to mx. Now, if you see this, this is y. This is x. So we're going to say that two things again. Acceleration is, okay, sorry, my bad. Direction of acceleration is opposite of direction of displacement. How do I know this? As there is a negative gradient. All right. Usually do this, show this on the side. A lot of times people might not be able to explain it really well, but if you have done this, the examiner is going to give you at least 1 mark in this, so you should always write this. The other thing is you should remember that the gradient minus g over r is equal to omega square negative. Do you guys understand? If you write this, then you get full marks. Understood? So you have to just explain them. That this is what a equals to minus omega square x is. Understood? Any questions now?
Could they, for example, give an equation that would not fit with the criteria that you showed on the right? And so we would say, show that the ball does not undergo simple harmonic motion. Could they ask that question?
It is quite possible that they might do
Yeah.
it, but
Okay.
there are only two conditions they might do it. They may give you like a equals to g over r times x if there's no negative sign. All right. And, or they could just give you a equals to minus g upon r x plus y, let's suppose. So that would not be this with y-intercept. All right. So that is only way. They could also, try to, this is just, I'm thinking, I've never seen a question like that, but I'm thinking they might also end up giving you something like x squared. So that also is a square function. So that would also be wrong. All right, Javeri? I don't think so. There is any other
Right.
possibility that they do it. All right. Okay.
So all these three
Then,
would be wrong, right?
sorry, all the orange ones
Yeah,
would
they're
be
all wrong.
definitely
He was giving examples according to the question, yeah.
Okay.
because they do not conform to the rules. One has no negative, one has a y-intercept, one has a square function. So that's not possible, right? Okay. Now, then says the radius of the curvature is 28 centimeter. Okay. Determine the time interval tau between the ball passing point P and okay. Interesting. Very, very interesting. Okay. Now, the radius of curvature is given to you, and they want you to find the time interval between ball passing P and returning to P. So it's going here, and then it comes back. This is what they want, right? Can you guess what is the, I say, okay, is this a quarter oscillation or a half oscillation or 3/4? What is it really?
This would be a, wouldn't this be half a oscillation?
It would be half oscillation. Yes, exactly.
Yeah,
It would be half oscillation, right?
it would be half.
Now, the problem is that we have the radius of the curvature. Radius of the curvature would be this. Now, when you see the oscillation happening, right? So radius means it's going to go like this or this. It's on a circle, right? So from the center point, wherever the center point, we could say that the amplitude of this oscillation has to be the radius. Can I say that, please? Think about it.
Sir, how did you come to that conclusion again?
Okay, what I'm saying is that suppose if something is going, like if this is a circle, right? And it starts from this particular point A and goes to B. So if it goes here, how much vertical displacement it has gone? That is x, right? This x.
Yeah. Yeah.
Isn't this displacement also equal to the radius?
Yeah, it is. Yeah, it is.
Right. So, yeah. So what I'm saying is that then we could say that the radius of curvature, whatever it is, would be the max. It would be the, if it's going to the maximum displacement, it would be that, right? The amplitude.
Yeah, it would.
Okay. So keeping that in mind, now we need to somehow think that how would we just justify it somehow that it gives us the time period, right? So thinking about that, one of the things that I know that for one whole oscillation, the omega is going to help us because we have this equation, right? All right. Now check the equation right here. Can you locate omega in this equation? Anyone?
G over R.
Is this one, right? You guys agree? Which means, can I say negative omega square is equal to minus G upon R? Then I can cut this off. I will say that this is going to be basically, I'm going to find this time period. So it's going to be 2 pi over t whole squared equals to G over R. Now check this. So 2 pi time period, I'm going to take under root on the other side. G is 9.81, R is 28, which is 0.28 in meters, right? Can you please help me find the time period for the whole oscillation? Yes, please. Today, Anusha is not here, right? Anusha is not here, and
0.336 or 0.33.
So is it 1.06?
So I got 1.06.
Yeah.
Can you check again? 1.06, right? So that is the time period. Is this the answer? This
Sir,
is
I'm
No,
getting
sir, this is for full
0.94.
oscillation.
0.94. Check again, please. I don't think so. It
Yes,
should be like
sir.
that.
I'm getting 0.94. I don't know why. Let me just recalculate.
Okay, let me check. It's confusing me. So, under root of, oh my goodness, where did it go? Come back,
It
please.
is 9.81
Okay, never
divided by
mind.
0.20.
9.81 divided by 0.28.
20. It's 28.
Why 20? It's 28. Mokshit, so it should be 0.28
Oh,
meters.
that's why I'm getting the wrong answer. Okay. Sorry.
Obviously. Okay. So then, now this
Sorry.
is basically a time period. Time period basically means that actually it goes from here to here, it comes back, and then goes to the other end, and then comes back. But he only asked us for going from P and back to P again. So should we half it off?
0.53.
Obviously.
0.53.
0.53. Okay. 0.53. Do you guys understand now? That's why there's 3 marks for this. Okay, very nice. Now it says that some moisture now forms on the track, causing the ball to come rest approximately 15 oscillations. Yes, yes.
I'm not
What?
getting 1.06. I'm getting 0.94. I think someone else got that too.
Really, sir, even I got the same answer.
I put 0.28
Okay,
as well.
let me try again. Are you using R? Are you using R as 0.28 or 0.20? What are you doing?
0.28 too.
0.28.
Okay.
I got exactly
Wait.
this divided by 2 pi.
2 pi. Why are you dividing by 2 pi? 2 pi divided by this value.
So it's 2 pi over
1.06.
5.92.
T is in the denominator.
Okay.
Rafe, do you see a mistake?
My bad. Yeah, I got it.
Okay.
Sir, I
I think
also
you guys are
understood.
tired today. Was it a long?
No, no, no. No, sir, it was
Okay,
not like
very
that.
good.
I just
Now,
forgot algebra for a second.
okay, well, that's not fair, but good to know. Then I need to, write equations like that too. But it's good that you realize your mistake. Okay, so
I
going
took maths long
to the
ago,
next
so I
one.
don't remember.
All right, but this is like very simple math. All right, sketch the variation of time, displacement x, first 2 periods of the moist. Sketch on figure 4.2 the variation of time of the displacement x for the first 2 periods after the. So this is going to be just like ever decreasing. Okay, everybody understand this? Do not change the time period. That would be a devastating mistake here. Everybody understands?
Sir, that was just a
Any questions?
roundabout way to ask us to draw a damping graph. The question
Yeah, but
was so
the
long
moment
for no
you see that
reason.
if some moisture is formed, then you should always realize it's a damping question. Okay. Yeah. Now, I will give you this as the homework because you see the same equation. You just need to realize, you see, he will ask you about how the expression shows that it is a simple harmonic motion. And then he's going to just ask you the same thing. He's given you the area, he's given you the density. You should know what A rho M basically corresponds to. And then you can find the frequency or whatever
Sir,
they're asking.
sir, for the
Yes.
graph,
Yes,
how do
yes.
we know how much to damp it? Like by how much we should
Just by like every peak should be smaller than the next previous one.
Okay, sir.
That's the issue. If it's light damping, if it's like heavy damping, then there's a different graph. We're going to do that later on. All right.
Okay, sir. Thank
So
you.
right now you do this as homework. When it is not SHM, right? Please just do this as homework and try if you could answer the questions here. Okay. Even if you fail to do that, it's all right, but I'm going to solve this tomorrow. Okay. So you can, obviously see if you're right or wrong about it, because now we've discussed it
Should we
a
go
couple
to
of
class
times
tomorrow?
why it's not tomorrow. I mean, next week. Okay. So just try to
Alright.
do these questions as homework, right? So how many, 3 questions for homework now, just to, recap what we have done. And finally, we'll move to the next thing, in the next class, whenever it is. All right.